Hello everyone, we're going to take a look at the last paragraph from chapter 5, real-world calculations, which all has to do with proportions, ratio tables, and so-called proportional and inversely proportional relationships. That are the two last bullet points from this list. Let's just start with a question. Classes B1A and B1B throw a party together. They will need 3 bags of crisps for every 5 students. They know that 45 students are coming to the party. How many bags of crisps should they buy? Okay, so if you know that you need 3 bags for 5, maybe you also know that if I would double the amount of students and I get 10, I would need double amount bags of crisps, right? So that means 6 bags of crisps. But here I don't have double the amount of students, I have 45 students. And they say 3 bags of crisps per 5. So what you should do here is, if you know there are 9 times as many students, how do I know there are 9 times as many students? I divide 45 by 5. There are 9 times as many students, so I need 9 times as many bags of crisps. So 3 times 9 gives me 27 bags of crisps. And that's the answer of the question here, right? And actually, I can use this to calculate how many bags of crisps I need for a lot of different so-called proportions, or ratios, you could call them in English. If I have 4 times as many students, I need 4 times as many bags of crisps. If I have 7 times as much, I need 7 times as many bags of crisps. Here, if I start with 35 and I get double as much, I double the amount of bags of crisps as well. If I have 7 times less, that's the same as dividing by 7, then I need 7 times less bags of crisps as well. And this table here is quite important. This is what we call a so-called ratio table, or in Dutch, een verhoudingstabel. And if we say things have the same ratio, then we mean in Dutch dat ze dezelfde verhouding hebben. So for example, we have the ratio 5 to 3. That's the same ratio as saying 20 to 12, or 35 to 21, 70 to 42, and 10 to 6 are all the same ratio. But it can be sometimes confusing because I would like to write down one ratio all the time at the end, right? Otherwise there are infinite amount of answers. So that's why we have made an agreement. If I'm talking about ratios in the end, I want to simplify as far as possible. So don't write down in your final answer 10 to 6, but write down instead 5 to 3. And we're going to practice this on the next slide, don't you worry. Just remember that the ratio for all those numbers, 5 to 3, 20 to 12, 35 to 21, etc., is the same. Okay? So the agreement is to simplify ratios as far as possible. How can you do that? Well, in the end, just take a look if you can divide both the numbers in the ratio by the same number, and then as large a number as possible, of course. So here I have 4 examples. If I have the ratio 2 to 4, I'd rather say 1 to 2, right? Because I can divide 2 and 4 by the number 2, which leaves me 1 and 2, so the ratio is 1 to 2. 50 to 60, I'd rather say 5 to 6. I divided both numbers by 10, right? Here I could have divided by 2 as well, but then I would be left with 25 to 30. And then I can divide by 5 again, and then I find 5 or 6 as well. So you can do it in one go by dividing by 10. In the end, you find 2 numbers which you cannot divide by the same whole number again, right? I cannot divide 5 and 6 by both by 2, for example. 72 to 63, I've divided them both by 9, right? 72 divided by 9 is 8, and 63 divided by 9 is 7. So this is the ratio that we in that case search for. And one more thing, I don't want fractions in my ratio. So 1 over 3 to 2, I don't like. You can do this 2 ways. You can search for a number that you can both divide by, right? So here I can say I divide both numbers by 1 over 3, right? Because if I divide 1 over 3 by itself, we all agree that we get 1 again, right? If you divide a number by itself, 1 over 3 divided by 1 over 3 becomes 1. And you can divide 2 by 1 over 3. How many times does 1 over 3 fit into 2? 6 times, right? If you find that difficult, you can also here multiply both the numbers by 3. Because then this becomes the whole number 1, and this 2 times 3 becomes 6, right? That's the same amount. Dividing by 1 over 3 is actually the same as multiplying by 3. Okay? Practice this. The first exercises are more about coming to know what ratios are and how you can work with them. And then later on in Theory B and C, we're going to take a look at proportional and inversely proportional relationships. But that will be discussed in another video. Good luck!